So today I will give a lecture regarding Module 2, Multi-Area OSPF version 2. All right. Okay. So here are the content under this Module 2. All right. Okay. First, introduction. Okay. So prerequisite, as usual, computer networks and OSPF itself. Okay, is an open shortest path. All right. Okay, and then we use a Dijkstra algorithm. Okay, we're not going to develop this algorithm. We just use this algorithm to solve the problem later that we develop and some do some troubleshooting issue. All right, use other command provided in the Cisco, in the Cisco device. And next, design to support hierarchical network design through the areas, and then key features, fast conversion, all right, and secondly, OSPF version 2 multi-area especially support very large variable length subnet mask and also CIDR, classless inter-domain routing. And then so when they implement OSPF version 2 also is a loop-free topology. Okay. And also it support authentication. And then this multi-area also efficient in large network, okay, through multi-area hierarchy structure. All right, so that's the purpose of multi-area itself compared to the single area. Okay, single area versus multi-area. So we need multi-area OSPF to keep OSPF efficient, stable, and scalable. That's the purpose in large network by providing them into smaller and also manageable areas. Okay, features, for example, structure for the single is the area 0, and for the multi-area OSPF, it will provide or supported multiple areas. Okay, to the main backbone is area 0. Right. And also links to advertisement flooding. So single, for the single, all LSA flood everywhere in the area 0. So but here we can constrain, can limited for the LSA traveling to other area. Okay, so LSA contained within each specific area, depends on the area. So they cannot beyond their area. So that's why we have multi-area of OSPF. And when we talk about scalability also, so scalability for the single, of course, limited. And for multi-area, we can have more and more and more, more area. Because that's we call the situation of the real situation, okay, for the real area. And that's the kind of the actual problem, so that's why we have this kind of topic, multi-area or SPF. Then routing table for this, for single OSPF, if you have a big size of the routers, even with a single area, it will have a very large compared to the multi-area. We make it smaller. Okay, from the big one, we make it a smaller. So that's why it means by smaller when we go for summarization. And then for conversion, slower for the single area because of that large topology, and faster and efficient for the multi-area because we divided that topology smaller or smaller. It's similar like when we make it very small and it become more faster and also efficient. Finally, they found that, okay, when we have this kind of multi-area or SPF. Right, next. Okay, let's break down why we need multi-area or SPF version 2, especially compared to single area. So here is the one that I already just now, yeah. So scalability, faster convergence, simplify management, reduce routing table, improve network stability, optimize LSA flooding, and also some example. All right. Okay. Next. The scalability. In a large network, SPF router exchange many link state advertisement or LSA. Okay, in a single area, every router must store and process all LSA, even for distant network. This causes high CPU and memory usage. So, and also it will affect the convergence. It will slow in convergence when changes occur because in large. Okay, multi-area SPF. So when it comes this kind of the techniques or method with the multi-area, it limits LSA flooding, okay, to within each area and making large network more efficient. Okay, we huge and then we divide it into multi-area, so the efficiency will be increased. All right, so that's a normal. Yeah. Okay. So this is what the thing they achieve when they implement this methodology, this multi-area, okay, compared to the single, yeah. Faster convergence. Faster convergence when a link fail in a single area, okay, and then we got loss of device. We have a big, big router, so many routers on, but only single area. So we can imagine that the convergence. Yeah. So mean when the link fail, yeah, in the single area, all routers must run the OSPF algorithm again. In multi-area design, only router in that area recalculate routes. This reduce SPF recalculation and speed up convergence. So this is one of the reason why faster convergence, because of the multi-area. So that's the case, the situation, all right? Third, simplify management. Yeah. So network can be divided based on geography, functionality, yeah, geographical issue, maybe function or department. Like ETM, KL, ETM, we divided that according to the geography or logistic, because one in the area in the central of the nation, one is in the south area of the nation. So this kind of thing we can do some manage. It's like VLAN. Why we do a VLAN and so on. Yeah. Okay. Problem come easier to isolate and troubleshoot because each area is smaller and independent. Okay. For example, area 1, engineering department, area 2, finance department, area 0, core backbone. Each can be managed by a different team with less overlap. Right? And then reduce routing table as well. So we can reduce the number of the routing table. So multi-area OSPF allow route summarization at ABR only. This means router in other areas see only summarized network, not every sub. This save memory and reduce routing complexity. And also improve network stability. When changes happen, for example, link down inside one area, the instability doesn't spread to other area. This kept the SPF domain more stable overall. Yeah. So optimize LSA flooding. So LSA are contained within their own area. Okay, so we can optimize that with the multi-area. ABR summarize and forward only necessary information. This reduces unnecessary traffic and keeps the LSDB or link state database smaller. Yeah. So summary from the advantage or comparison between these two, which is among single and multi-area, are first scalability issues, LSA flooding, and regarding shortest path findings, recalculations, okay, route summarization, and also stability issue. Yeah, so that's a summary that we mentioned just now during my lecture. Okay, OSPF area hierarchy. So OSPF divides the network into area more manageability. Area 0 for the backbone, which is core of the OSPF network. All other network must connect to area 0. Non-backbone area connect to area 0 through ABR. Okay, do not share, let's say, directly to other areas. Okay, example topology, this is an example, like say if you want to create like this. And also the following router types, okay, router types in multi-area. So when you create that, we categorize that router, which is for that area as well, and so on. So like internal router, all interfaces in the same area, we call internal router. Backbone router located in the area of 0. Area back border router or ABR connects two or more areas. And for autonomous system, mean autonomous. So mean another routing. Okay, we're trying to communicate or we want to propagate the packet. So we must have a ASBR. We call this in here. They call ASBR. Okay, router in order to manage it. We put the type of the router in the multi-area right now. Yeah. So LSA types. So LSA types first, we have router LSA generated by router, least directly connected links for the network LSA that generated by DR represent broadcast network. For summary LSA generated by ABR, advertises network between area, and SBR summary, okay, which is generated by ABR itself and tell other area how to reach an ASBR. And XTSR advertises external routes, for example, from EGRP or static routes. So not from EGRP, maybe they are using RAP. So any other protocol, yeah, or any other network protocol they are using. So if we are trying to communicate with the others or for the static routes. Then for configuring multi-area OSPF, okay, I just give us what I call example only. Okay, as I told you, the real, the exact one, if you can find in the file folder, which is module 2B. Yeah, that one is the correct one, reflect to the network. This is just the example of the topology and also the configuration step that you need to configure in order if we have the multi areas. Okay, that's the purpose of this slides. Not exactly the code is correct or not. Yeah. So the one that in the version or 2B, that one is correct, which is reflect to the topology itself. So this is part of the code that you need to configure in order to activate this kind of the method or method multi-area. So multi-area OSPF version 2. Yeah. All right. So route summarization. So to reduce routing tables, summarize routes at the ABR. So this is part of the commands. Okay, benefit smaller routing table, reduce SL fatigue, faster SPF calculation. This one also I already mentioned during the beginning of this slide. Yeah. Okay, verification command. This is available. You have to remember that. Maybe this one during the activity, I will put that. So you need to know how to use it because we will use to diagnose. And then after that, provide a solution how to fix that. Okay, through with diagnosing command, we can differentiate to investigate what are the problem, what are the missing things whatsoever, and then solution. We have the problem. Our activity will have a problem normally, problem or cause, yeah, problem, and then state the after problem, put the cause and also the solution. Okay, so either maybe there is a different word, but normally we need to state the problem. I already mentioned what kind of the things that are missing normally, yeah, in the activity. Okay, from that, so put the cause, and then what are the what you call this cause? We have to mention that, and then finally the solution. That's very important. Okay, so that's a troubleshoot style. Okay, so we use this in order to troubleshoot scenario. Our scenario in the all the activity later on. Yeah, all right. So common troubleshooting issue, yeah, this is a common problem. Okay, as I told you, okay, like you have to specify the problem. I will specify the problem. So you need to find the cause. We need to find the diagnostic algorithm, how to check that, and then what are the solution you need to provide, or you need to fix the solution. So solutions, in order to solve the problem stated in here, like area not forming adjacency. So the possible cause, this is just example, maybe area ID mismatch. So how you have to show that normally. Okay, I already mentioned that activity. I stated that kind of the, let's say if I cause this, so that kind of things, you can try that. So you have to state, okay, every problem, there's a common problem actually, and then you need to familiar with the possible cause and also the solution. So later on we'll check back. Okay, so this, by we doing this, we can be expert as a network admin later on if we work as a network manager, network administrator of the certain company in order to manage all the network if I using the OSPF. Yeah, all right. So missing route, for example, so the problem cause is ABR not advertising. So solution, check area range or LSA filters, and how you need to do this one in the activity. You have this kind of the, okay, just this I give the some synopsis of the problem. Okay, so during the lab you will explore more of the solution. Maybe in the real device different, because real device issue that we have many devices and many models, so that's why we can have a lot of things, because luckily in our lab we got all these real device. So later on, after we have done a lot of packet tracer, maybe we got time, we have to go that real device, and then we can find out. Okay, when we jump into that real device, we can see how you later on you want to be expert on that network, because in the outside, in the real, after you graduated, all right, so you will, I mean, facing this kind of the situation, like troubleshoot, right? Because we are computer scientists, I never admin, so this is our job. First of all, we use packet tracer, unless if you have the packet tracer design, you need to keep on trying. Okay, that's why we use packet. I told normally in the during the class, right? So we use packet tracer or whatsoever network tool to simulate first, to troubleshoot, to check whether our solution is correct or not. That's very, very important. Not straight away go to the real device to fix that. So it will make you trouble. Not just for yourself, your company, your place that you work for, it will become trouble. Okay, so this is the what we call the step you have to do it do it as a precaution. Yeah. So slow conversion and SSCLS because of that, and we need to enable summarization and routes from other area missing. So means no correction very zero. So ensure backbone connectivity. So you need to verify that. Maybe packet tracer. Okay, we got lots of things. Okay, but packet tracer is good for our Cisco product because they create this model which is stated in the packet tracer. Similarly, I can say 90% similar to the real device. Okay, I'm not sure for the GNS3 tool or other tools. Okay, that's why here we are using, and also we have a device for the Cisco device, so we can go straight away. Okay, we have got, I mean, real experience to use a real device later on. Yeah, unlucky, we got very few device because the cost is very, very expensive. Each of them almost, I'm not sure, I think almost 20,000 each, that something like each, yeah, each island that you saw in our lab. Okay, all right. Okay, so next, okay, summary. So multi-area basically improves scalability and performance. Always maintain Azure as a backbone. This is a compulsory, and use ABR to inter-area communication means for another protocol for the RIP to communicate to another, not just we communicate between us. Okay, so they provide ABR type to communicate to other protocol. Okay, for the RIP, for the okay, just now as I for EGRP, for example. So that's a very important thing. And implement route summarization for optimization. Finally, use verification common to validate configuration and also link state database. All right. Okay, so this some sort of the assessment question that very simple, that maybe to just refreshing that whatever you heard just now during the lecture. Yeah. All right. Okay. That's all. Thank you for listening and watching. Bye bye.